So I started a little late, but now this is all being recorded. Anyway, so the Milky Way is one of the brightest and most obvious features that we can see at the moment. And there's a lot of really cool things going on within the Milky Way. First thing I want to talk about, if we're going to talk about Mars, we're going to talk about war and combat, odds are we're going to want to talk about the weapons of war, or kind of what's not a weapon of war. I want to start with this bright star here. You can see there's kind of an arc, and that arc leads to this star right here. From there, we can go down to this star right here, across, and then over like there. So we've got a four-sided shape. That is the shape of Scutum, and Scutum is a Roman shield. Now, this picture doesn't quite do it justice, as scutums in Rome were often big and rectangular. They were actually so big that a group of Roman soldiers coming together could use them to basically cover themselves from every direction, almost like a turtle, and that's what they called it, a turtle formation. Anyway, there's a lot of things going on in Scutum, but I want to pull our attention to a deep space object. This is going to be something in the sky that is not a star, it's not a planet, it's something else. So, we're going to be looking in the direction of Scutum and at these deep space objects. Now, one of them is labeled, and I want to bring our attention to it. It's not the most violent thing in the world, it's the wild duck cluster. Let's take a look. This thing is awesome. It's a little low resolution here, but a couple days ago, the Cosmic Club, the Astronomy Club at New Paltz, went observing using the Smolin Observatory on campus. We actually saw the wild duck cluster as well as a lot of other things, but I have to say the wild duck cluster was one of the most impressive things. It really glows brightly in a way that things like nebulas don't quite in a telescope. I think in Stellarium, in this program we're using, things like planetary nebulas, you can see all the colors, but those are not true color. You know, when you look at nebulas and they glow green and blue, a lot of that comes from looking at different light and kind of photoshopping them all together. But this looks super impressive out of a telescope. Anyway, a little more about it. This is a globular cluster. So it's a bunch of stars that all move together around the galaxy, but they're not kind of the normal groups of stars like our own sun is. These stars are all very old. There's a lot of them, and they're very rich with metal. And that is specifically strange. Stars that are rich in metal often formed very late into the universe, very close to our current time. So why do they have all this metal? It's a really good question, and we're not quite sure. Normally, blue stars, which we'll talk a lot about, are bright and hot, and as they glow blue, they burn through their fuel very, very quickly. They explode and release a bunch of heavy elements into the surrounding gas. When stars form out of that surrounding metal-rich gas, they're a second generation of stars. But these are very, very old, yet they also are metal-rich. So that's quite confusing. We're not entirely sure why, but that means there's more research to be done on this wild duck cluster. And personally, I don't know about you, but the geese at New Paltz can be pretty scary, so maybe wild duck is a relatively violent thing. Anyway, zooming back out to the night sky. I want to talk a little bit more about Scutum and the Romans, because in the stories of conflict, the Romans are one of the first you want to talk about. So, these Romans, of course, conquered the entire Mediterranean at one point in history. They came out of Italy, but on their way to conquest, they had to stumble upon Greece. Now, Greece, of course, is known for its philosophers, for its math and geometry, and there's actually a particular constellation that has to do with all of that. Now, I'm going to get there, but first, if we're talking about the Romans, we should talk about their gods. And you may notice there is a bright object right here near Scutum. I'm going to zoom into it. You can see in the top left it's Jupiter, and there we go, the largest planet in the solar system. There is a ton to talk about here, and I don't think this picture quite does it justice. So we're going to switch programs for just a second and talk about Jupiter and the solar system. So here we are at the entire solar system. You've got the inner planets, Earth, Mars, Venus, and Mercury. Then this next planet out is Jupiter. So let's take a closer look at it. So now we're going to be zooming in on the largest planet in the solar system. Oh, I know what happened. I need to actually tell it that I'm not sharing Stellarium anymore. Thank you guys for pointing that out. Okay, I'm going to stop sharing for a second and put us back. Here we go. Now we should all be on Jupiter. Thank you guys for pointing that out. I would have just kept going. All right. Here we go. So, here we are at Jupiter again, and I'll quickly back out to show you guys what exactly we were looking at. So, of course, that's Jupiter. And then we've got the rest of the solar system, the sun and the inner planets, and then Jupiter right here. So let's take another look back at it. Yeah, if anything continues to not work, please let me know and I'll get to them as quickly as we can. So, Jupiter, couple things about it. Firstly, Jupiter is the largest planet in the solar system. So much so that besides the sun, if you add up all the mass of everything else in the solar system, it's about the mass of Jupiter. Saturn, the next biggest, is not even half the mass of Jupiter. This thing is huge, and some people consider it a failed star. However, it has less than a single % of the sun's mass, so whether you consider it a star or a failed star is kind of up for interpretation. But Jupiter has a lot of violent and incredible activity on its surface. Firstly, I want to bring our attention over here. This spot right there is the Great Red Spot, and it is a giant storm that has been brewing on Jupiter for at least 300 years. It was first spotted by Galileo in the 1600s. These different colors are different bands of wind. One's going this way, or I think this red one is going over this way, and this white one is going over that way. The friction between the two is driving the storm like a huge hurricane. But even beyond the surface of Jupiter, there's some very interesting activity. I'm going to zoom out to those Galilean moons. Galileo saw the big red spot, and he also saw these 4 moons of Jupiter. As you'll notice, they seem to line up right here. This is Europa, Io, Ganymede, and Callisto in that order. And they line up quite often, actually. These orbits are what's called resonant. They tend to line up very often. The time it takes Io to go around 4 times, Europa goes around twice, and Ganymede goes around once. This creates incredible activity. Actually, I think we're very close to a significant event. Here we are, right here. Io is on one side, Europa and Ganymede are on the other. And just like the moon affects the tides on Earth, these bodies and Jupiter all affect the tides on each other. Now, if we actually zoom in on Io, you'll see the effect of all those tides. Ooh, and we may pop through Jupiter. All right, there we go. But here we are at Io, the most volcanically active system or planet in our solar system. Well, not planet, but the most volcanically active body in the system. All these black dots are points where lava is erupting through the surface. It is an incredibly hot planet, or it's an incredibly hot moon, and even though it doesn't have any internal heat the way that Earth does, where Earth just hasn't cooled down from when it formed, Io is getting heat generated by Jupiter and the other moons. So, Europa and Ganymede actually have that same effect as well, but to a lesser extent. They are heated a little bit, and Europa actually has a lot of water on it, which means that heat plus water means that there's the potential for life to be on Europa as well. All right, I'm going to stop sharing and bring us back to Stellarium and bring us back to Jupiter. All right, there we go. So that's a little bit about Jupiter, and here are the moons of Jupiter, as well as a couple other smaller ones, Amalthea, Metis, and Thebe. Anyway, we zoom out a little bit, and we're back to the sky. Now, as I said, I was originally talking about the Romans. So, the Romans, of course, conquered Greece, and when they did that, they encountered Archimedes, one of the most famous Greek philosophers of all time. And they saw him in a room with a bunch of circles. Archimedes looked at these Roman soldiers, and he knew he was going to die. He knew they were going to kill him. But what did he say to try to defend himself? He said, "Do not disturb my circles." That did not work. They ended up killing him and disturbing the circles. But that's where Archimedes' kind of life brought him. Now, of course, the Greeks are incredibly fascinated with geometry. And what better way to honor them than by putting the most famous kind of geometric shape in the sky? In order to find it, we're going to have to look at some of the most famous constellations in the night sky. In the northeast, very high up, you have this W shape right here. This W is the constellation of Cassiopeia. It's a very easy constellation to see. From there, you can see it's creating kind of an arrow. That arrow shape, if you follow it, brings you to this star right here. You've got kind of an A shape. This A stands for Andromeda, another very easy to see constellation. Now, if you continue in that direction, if you kind of follow the arc of Andromeda, you'll end up at this star right here. This star is a little triangle, or is part of a little triangle, and forms the fittingly named constellation Triangulum. Here, let's just take a look at Triangulum. And, well, as a picture, it just looks like a triangle. Anyway, there's a whole lot to actually talk about within Triangulum, once again because of a deep space object. If we open up that map of deep space objects again, we get the Triangulum galaxy up here. Now there's a whole lot actually showing up right there, so I may not click on it immediately. Yeah, let's get a little bit of a better look. And here we have the Triangulum galaxy. Now, those of you who know about Andromeda may know of the Andromeda galaxy. It is the closest one to us and the biggest in our local group. The local group is the collection of galaxies that are very close to us and we're attracted to them by our mutual gravity. Andromeda is the biggest galaxy. The Milky Way is the second biggest one, and this is the third biggest. the Triangulum, or the Pinwheel Galaxy. You can see that pinwheel is a pretty fitting name given its shape, but this shape can actually tell us a lot about its structure. This shape is what we call a flocculent galaxy. It's one of my favorite words in astronomy. Flocculent kind of means fluffy. It means, in this case, very filled with stars. There's lots of stars forming in this galaxy. And we can actually see some spiral arms in this galaxy. You've got one that kind of goes up over here, another that kind of creeps down over there. Those are kind of the two most obvious, but there's one around here and maybe another that's going on down here. However, you also see gaps. There's a gap right over here, there's a gap right over there, and well, there are still stars there, but they're not blue stars. I was talking about blue stars earlier with the globular cluster. Blue stars are big, bright, and hot, and that tells us a lot about the galaxy that forms these stars. So there's a lot of blue stars here, but they don't have time to actually leave the arm of the galaxy because, well, that takes millions of years and they will burn up and use up all their fuel before that. So there's active star formation where there are blue stars, and there's not active star formation, or not as much, where there are no blue stars. It's used very clearly as an indicator. Now, it takes about 230 million years for the sun to do one loop around the Milky Way. So in that time, the largest stars, the biggest and brightest and bluest, can easily go kaput. And we can figure out a lot of this by looking at the Triangulum or the Pinwheel Galaxy. Whoop. Okay, that's kind of all the way zoomed out. Let's take a better look. So, over here, as I said, we were going to talk about Mars a lot. You can actually see it is right over there. If we move through the night a little bit, it gets even higher, and there's a bunch of constellations around Mars that I want to talk about to better understand Mars itself. Well, Mars, as we were talking about the Romans, is the kind of equivalent for the god Ares. And Ares is actually up in the sky as well, but not in the way you may think of it. Right over here, there's a little kind of hook shape. It continues to this star way over here. That hook shape is the constellation Aries. Now, that may not be the kind of Aries you were thinking of, but I bet a lot of you know this. This is the zodiac Aries, the goat. And in the mythologies, it is a golden goat. It has golden fleece. This fleece was very highly sought after, so it had a lot of stories that involved it. This is a ram from Colchis, an island in Greece. And at one point, this golden fleece was guarded by a dragon, so no one could actually get it. However, the people who eventually stole it were actually Jason and the Argonauts. So there's a lot going on with this constellation. And it actually used to be associated with the coming of spring. There was just a quick question. There's a FPS in the bottom left. That just talks about how quickly the display is updating. It doesn't really matter. It stands for frames per second. It's just how quickly the internet is showing you guys what's happening. Anyway, so Aries itself used to be associated with the start of spring. Aries lies on the ecliptic, this line here, and that line contains all the zodiacs. It also used to contain the equator, but now it doesn't. The Aries zodiac are people associated around the time of the end of March and beginning of April. But that has actually shifted. The modern definitions of zodiac would place that within Pisces at the moment. That brings me to the next constellation. So, in some ways, yes, those people who think they are in Aries are actually not, depending on your modern definitions. Anyway, getting to Pisces. Pisces has a V shape right next to Aries itself. Okay, let's get rid of these lines. They're not, uh, they're just imaginary lines. Anyway, you've got this V shape, which is the start of Pisces. From there, you've got a head that comes up here, and then another head that goes up that way. It's relatively complicated to talk more about the equator. It's related to precession. If you're still curious, ask at the end of the show, and I can happily go into more detail about it. Anyway, that V shape forms Pisces. So Pisces is two interconnected fish. And these fish are related to Mars or they're related to Aries. These fish represent Aphrodite and her son Eros. As I've mentioned, a lot of gods have both Greek and Roman counterparts. Aphrodite is Venus, Aries is Mars. You may not have heard of the Greek Eros, but you've probably heard of the Roman version, Cupid. That's kind of how you can think they're related. And they are fish because at one point they were trying to escape a great battle. At one point, Typhon, a big monster, was attacking Mount Olympus, the home of the gods, a huge giant mountain. And Aphrodite and Eros, not one for combat, actually turned into fish and swam downstream. They were connected by a cord, and that cord is actually represented in the sky as well. Of course, you have right here, but even this bottom star is very easy to see relatively, and that star is named Alresha, which is Arabic for the cord. Alresha is interesting for a couple of reasons. Firstly, it's 300 light years away, which means that the light we saw, or that we see when we look, was sent 300 years ago, and it's been traveling ever since. In addition, this star is a blue star, which we've been talking about a lot. This star is about double the mass of the sun, but it is 30 times brighter. It's using up a lot more energy every instance. So this star is not going to live as long, but it's going to be bright and blue, and that's partly why we can see it in the sky. Now, of course, if we're talking about Mars and Aries for so long, it's about time we get there. Going to zoom in, you can see Mars and its two moons, Phobos and Deimos, which we'll actually get to. Oh, don't want to lose Mars. So, I may have mentioned this at the start, but let me say it one more time. This next couple of weeks and the past week are one of the best times to see Mars. In basically plus or minus 5 years, this is going to be the best and easiest time to take a look at the red planet. Now, there's a lot to see, so I'm going to switch sources and we're going to go and look back at the actual planet in better detail. Here we go. So, as I mentioned, we were looking at Jupiter previously, but now let's get a better look at Mars. As we zoom through the solar system to get there. It's going to be coming up right in the center and may kind of pop in a little quickly. Yeah, there we go. So here we have Mars. Now there's a lot going on Mars. Firstly, it is the fourth planet from the sun. This means a couple of things. It is very, very cold. In addition, Mars is half the size of Earth in terms of, if you took a ruler and measured it, but it's only a tenth of the mass. That means it has a very low gravity. That gravity contributes in a couple different interesting ways, though. Firstly, that allows huge volcanoes to form on Mars. If you look, there's these different dots 1, 2, 3, 4. Those are all the volcanoes of Mars. But that's not its most impressive feature. You have this one right here. This is Olympus Mons, exactly what I was talking about earlier, Mount Olympus, or, well, it's named after Mount Olympus. Olympus Mons on Mars is the largest volcano in the solar system. Io has the most volcanoes. Earth, we could say, has some pretty cool ones and some pretty useful ones, but the Martian one is the biggest. It reaches about 14 kilometers above the surface of Mars. For reference, I believe Mount Everest reaches about 7 or 8 kilometers above the surface. So this thing is huge. It's very wide as well. Of course, we can see it from space or with an extremely good telescope. But this volcano is bigger than Washington State. It is bigger than entire countries. This thing is absolutely massive. This hints towards geologic activity on Mars. Now, Olympus Mons has been dormant for a while, but there's lots of other shapes that suggest things have been going on Mars. Here, you have the Valles Marineris. Is something incredibly large. It stretches further than the continental United States. It is a huge canyon, deeper, at least twice as deep as the Grand Canyon. These features on Mars are absolutely massive. If you go up to the North Pole, you may not see much, but if you go down to the South Pole, I definitely didn't just screw up right there. I meant to go straight to the South Pole, but that's whatever. You can see an ice cap on Mars. Let's speed things up a little bit and watch Mars rotate. So that ice cap is not quite what you think. This ice is dry ice. There is water ice below there, but you're seeing solid carbon dioxide. It is so cold on Mars that carbon dioxide, dry ice, the thing that makes kind of fog or smoke machines, will just instantly solidify. So there's a dry ice cap on Mars covering a solid ice cap, kind of normal water ice cap. We know that there definitely was water on Mars at one point. We know there's still little bits of evidence of water on Mars these days. But I want to finish this presentation by talking about some new discoveries. There is lakes underground on Mars. So I'm going to stop one more time. I'm going to get something going. All right, now let's go share it. So here we have a lot of talk about salty lakes on Mars. So firstly, this is new research that came out last month in September. Firstly, a little bit about Mars. A lot of this I've mentioned, but you can kind of weave it together into a nice cohesive story. So Mars is further away from the sun than Earth is, and it's smaller. Those two factors determine almost everything. So at one point, Mars had a nice thick atmosphere. It had very Earth-like conditions. There was flowing water on its surface. There may have even been the potential for life. However, Mars is small. It has a magnetic field, but that field is much, much weaker than on Earth. That magnetic field also got weaker and weaker over time. It got weaker, and therefore Mars started to lose its atmosphere. The size or the mass of Mars didn't help either. That atmosphere just got whipped away by the sun's energy. The temperature started to drop. Dry ice, carbon dioxide, started to sublimate out of the atmosphere and into the rocks and ice caps. This dropped the temperature further, and here we are. Mars seems to be a frozen, dead world. However, new research was discovered that can kind of suggest otherwise. So, right up here, this is a picture that came out in 2018. This dark blue patch is a lake of water underneath the surface. It's possible that this could have liquid water. The new research of this year was that not only is there water there are nearby lakes as well, with similar types of water and similar sized lakes. These lakes are under intense pressure because they're underground, and these lakes are incredibly cold. The only explanation for how they could have liquid water is that these must be incredibly salty. Now, this is more of a brine than kind of salty water that you might think of on Earth, but it's something. How was it actually discovered? Well, by the Mars Express. It used ground-penetrating radar. Basically, it shot radar down into the Martian surface. A lot of it would bounce back up and not tell us much, but if there was a cave or underground lake or other structure under the surface, we could pick up that signal. We know that this works because we have actually done very similar missions and found underground lakes in Antarctica. There is an extremely useful comparison. Lake Vostok in Antarctica, right about here, is an incredible specimen. Under miles of ice, under miles of glacier, you get a salty, cold, high pressure lake. This sounds very similar to what's on Mars. We have a very strong suspicion that there is life in Lake Vostok as well. There's salty water, but some bacteria can live, and then crustaceans eat the bacteria, and suddenly you've got life. The big difference is that we know there are geothermal vents heating up Lake Vostok. There's a source of energy. Is there a source of energy on Mars? Well, there definitely was geologic activity in the past. If there's enough currently to have life currently alive, we don't know. That's $1 million question. But it's a useful comparison. So, big question. Is there life on Mars? First off, there's no little green men. There's no multicellular life on Mars. We're talking about very simple bacteria. However, water was once very abundant. There was a good supply of heat. There was a thick atmosphere. Basically, everything we would need for life to evolve. Now, as Mars became less and less hospitable, it is possible some of that life became what we would call an extremophile, and they learned to live under the harsh conditions that Mars currently has. It's possible that there is still bacterial or single-celled life on Mars. We don't know. However, if there is, these underground lakes are a very good place to look for them. Now, with that, that's the end of my presentation. If you guys have questions about the astronomy, about the mythology, about the history, about Mars, the zodiacs, the ecliptic, anything else you'd like to ask, now is the time, and I want to thank you guys for coming. Yeah, you can ask via the chat or by the Q&As, the Q&A section. So firstly, why does the equator not match it anymore? Well, the Earth is spinning in its in the way it revolves. It revolves around itself, around the North Pole, but that actually wobbles a little bit like a top. That top motion is called precessing. So the North Star actually moves as well, and everything moves in tandem. 2,000 years ago, when the Greeks decided which zodiacs were which, the Earth's North and South poles were in a slightly different position than they are today. And that's changed a whole lot of things, not just the zodiacs. Thank you very much, Mary. Yeah, if anyone else has any questions, feel free to put them in chat, or yeah, as I said, in the Q&A. I'll give it a couple minutes in case anyone is trying to type out their questions. I know it can be a little difficult to express them in online. Thank you very much. Yeah, so for what it's worth, the Planetarium is currently doing virtual shows on the SUNY New Paltz YouTube channel. If you look up SUNY New Paltz, I think it's called Looking Up, is kind of the series of Planetarium shows. We've put up about 4 or 5 YouTube videos of the Planetarium at this point, including 2 by me. So check those out. Timetable for the next time Olympus Mons becomes active. Currently, we don't think it is ever going to become active again. However, if we find evidence for kind of a periodic cycle, then we could probably apply that. At the moment, I think we suspect that Olympus Mons is just extinct. So how different is the night sky between Maryland and New Paltz? Not very much. So the latitude of New Paltz is about 42 degrees. If I had to guess, the latitude of Maryland in the DC area is probably something like the upper 30s. As soon as you have kind of a 20-degree latitude difference, that's when it starts to make a difference. So there was a question, what kind of planetarium system do we have? Well, so firstly, we have a projector with this setup. I can do this stellarium show. However, we also have what's called the Spitz Starball projector. It was built in the 60s, and as far as we're aware, you can't really get this type of thing anymore. It's basically a big sphere with holes poked into it and then a light in the middle. You can get the entire planetarium very dark and create a very nice show. But yeah, so our main kind of drawing point is the Spitz Starball projector. Yeah, so as I said, this semester we're mostly doing virtual shows. However, as soon as restrictions are lifted and we can be safe about it, I'm sure we'll be bringing in normal shows back. Well, it seems like the questions are starting to. Oh, the YouTube channel is the SUNY New Paltz YouTube channel. So if you look up just SUNY New Paltz, SUNY New Paltz Astronomy, I'm sure you'd find it. SUNY New Paltz Planetarium, anything like that, you'll probably find the right stuff. How can you spot Mars and Pisces in the sky? What do you look for and how to find it? Well, so Mars specifically is very easy to see. It is bright, it is red, and it is usually in the kind of southern part of the sky. Basically, if you see a star that is brighter than all the ones surrounding it and it looks a little red, it's probably Mars. Today, I just said Pisces is the constellation behind Mars. Normally, it's a kind of difficult to find Pisces. If you can find other stars or constellations on the ecliptic, such as Taurus is an easy one. Leo, Gemini, sometimes Capricornus is relatively easy to see. What you can do is start to connect those constellations and see if you can kind of trace out the ecliptic line. And from there, you can find all the other zodiacs that you can't see or that you couldn't find. But Pisces also has a very obvious V shape. Can I see the space station when it orbits over our area? Does it go over New Paltz? Not super often, but the International Space Station definitely does. Or yeah, in Maryland, it's probably fairly similar. You can look up where the International Space Station is. It's freely available on the internet. So if you see something moving very quickly and it's at the same time the website says, oh yeah, you should probably be able to see it, that's probably the right one. Yeah, and it goes the same for New Paltz, Maryland, basically anywhere. You can look up where the International Space Station is. All right, well, I'm going to stick around for another couple of minutes in case anyone has any last questions. But once again, I just want to thank you all for coming. I hope you guys had a good time. Hope you learned something. And yeah, thanks for coming.